Hello, good morning everyone. We would like to call to the stand Mr. Doug Cochrane. He's a professional engineer, lead AP. He's recently received his CDP certification. So, he's the most suitable person to talk to us about decarbonization procedures and how can we learn more about decarbonization in general.
Good afternoon, everybody. My name is Doug Cochrane. I'm a director at large with Society, so I currently sit on the ASHRAE Board of Directors. As part of my other hat, I am the board EXO to the Training and Education Committee, so you're going to hear more about what ASHRAE is doing. I talked to Dimitri yesterday, so I'm going to go a little off script the way I'm going to start this, in that I'm going to tell you what ASHRAE is doing for decarbonization. Where we sit, what's available, what resources are available. Some of them are free, some there's a cost, but I think it's important that everybody knows what ASHRAE is all about when it comes to decarbonization of the built environment. So first off, as a distinguished lecturer, they asked us to put in 2 slides. So the DL, Distinguished Lecturer Program, is brought to you by the Chapter Technology Transfer Committee. The presentations or opinions do not necessarily reflect the position or policies of the ASHRAE or the chapter. You should be getting a DL evaluation form. Please fill those out. Society likes to know what's going on with the DL program, how we can improve it. It's something where, ASHRAE pays transportation for us to travel internationally, locally or internationally. And then the chapter helps out with expenses here. I think it's important that people hear from people that know what's going on in particular matters. The second slide they ask us to show is ASHRAE is a volunteer organization. We rely on members, like a lot of people in this room, to do a lot of the work. And I can tell you, the more you get involved, I think you get more out of it. The one thing that probably a lot of people aren't aware is ASHRAE has over 100 technical committees. So whether you're interested in specific equipment like chillers or air handlers, or you want to talk about resiliency, climate change, there's a TC for that. So I encourage you to go to ashrae.org, check out the TCs that are there. You can apply on the spot to become what's called a provisional corresponding member. That way you'll get all the notes, all the correspondence from that TC, see what's going on and see if something that is of interest to you. So I strongly encourage you to do that. So we talked about what's ASHRAE doing for decarbonization efforts. So first off, ASHRAE came out with a position document. It was passed by the board in June of 2022, was just reaffirmed by Technology Council in 2024, January. It's 16 pages. It is a free download. So I encourage you to take a look at that if you haven't seen it. So some of the key points out of that position document is that projected building stock is expected to double by 2060. Buildings are responsible for roughly 40% of energy-related greenhouse gas emissions. Now, the next points are what ASHRAE's stance is, and some of these goals are pretty aggressive, but I think it's important for you to know where ASHRAE stands. By 2030, the global built environment must have its 2015 greenhouse gas emissions. All new buildings are net zero greenhouse gas emissions in operation. So we're just talking about operational carbon, we're not talking about embodied carbon. There has to be widespread energy efficiency retrofits of existing assets well underway. And embodied carbon of new construction needs to be reduced by at least 40%. This is by 2030, which is just over 5 years away. A lot of countries, public and corporate entities, have committed to being carbon neutral prior to 2050. It's great that people have that plan, but now is the time for action. We have to put policies and procedures in place in order to achieve those goals. From ASHRAE's perspective, by 2050, all the latest and new existing assets must have net zero greenhouse gas emissions across their whole life cycle. So that's both operational and embodied carbon. And lastly, if people heard President Dennis Knight this morning, workforce development. Equip the future workforce with skills to support building decarbonization. So that's what we're working towards. If you're not familiar, ASHRAE has what's called the Center of Excellence for Building Decarbonization. So it's now a permanent committee that reports to ExCom of the board of directors. It used to be the Task Force for Building Decarbonization, which is just a temporary thing, so we made it permanent. Their main focus right now is concentrating on guides to help members. So developing the guides, and we're going to go through what guides are available, etc. But that's been the major goal of the CEBD right now. Take a look at ashrae.org/CEBD for all the latest info. It is updated regularly. I encourage you to look at it, see what's new going on. As things develop, that is what's being updated. Any questions you have, please send to dcarb@ashrae.org. So let's take a look at the guides. There's some guides out, there's some coming. Start off. Building performance standards. This is a free download. This is based on operational carbon only, but it is a free download. So you're welcome to go to CEBD and take a download on that. Something that came out very recently is the how-to guide for heat pumps. Everybody's heard about electrification using heat pumps. This guide was put together to help people do that. Again, that is a free download. And we wanted to get it out quickly, so what happened is we came up with the preliminary guide. There'll be a more advanced guide early in 2025. Grid interactive buildings, that also has been published. You'll see that it is available for purchase. The reason for whether you have to pay or it's free is whether we've had any government funding or outside support to help fund those guides. Where we haven't, we just want to get reimbursed for the cost we've done. The one thing that the CEBD has done is used outside contractors to help speed up the process to get things out in your hands quicker, so there's a cost to do that. Decarbonization of hospital buildings, again, that's out. You can see what the prices there are. Everything is in US dollars. And you have an option to do both, either you want a printed copy, a PDF, or you want both. Something that came out fairly recently is TM65NA. CIPSE had the TM65. This has now been updated for North America, but it also applies to other parts of the world. Probably what you've seen if you're trying to do a whole life cycle analysis is the lack of equipment product declarations, or EPDs. This helps you be able to come up with what the values are in order to do that life cycle analysis. So that is out. You can see the cost there of what it is to do it. Two guides that are still to come out. There's one on retrofits for commercial and multifamily buildings that hopefully will be out later this year. Cost to be determined. And the last one, which I know is a lot of work because I know a few people that are on that, is the whole life carbon guide for building systems, including both embodied energy and carbon. And that's due early in 2025. It's great to have these guides, but we need to be able to tell people how to use them. So I can tell you the Training and Education Committee is busy working with the people that have come up with these guides to develop the courses for these guides and also relevant topics. So to give you an example, if anybody is going to Orlando for a winter meeting, 3 courses that really address decarbonization in different ways are being offered in Orlando. Solar energy system design, application, and real-world strategies, advanced design for zero energy and low carbon buildings, and ultra-low energy buildings and microgrids. So with these guides, there's more in development. You'll see more coming, and that's why I encourage you to check out that website, because it'll be updated as things happen. Okay, does anybody have any questions on that before I get into what the topic is? Normally this presentation I do is interactive, so that I get input from you, but due to time constraints I can't do that. So I will go through it. I'm happy to answer any questions that's here. So we're going to talk about system and equipment selection, some decarbonization, and how does it work? A simple example, and then a wrap up. So what are the criteria? This is where I would normally ask you to, what you think is important in system selection. So part of what's in the 2024 ASHRAE handbook on HVAC systems and equipment is HVAC system analysis and selection. So what's in there under system selection? You got to consider temperature, humidity, air motion, air-water velocity, water quality and/or reuse, outdoor air quality or purity. One thing when you're talking about indoor environmental quality is you want to make sure you're not bringing in air that is not fresh. In other words, if you have high CO2 levels for outdoor air, you have to make sure that you're bringing in enough fresh air in order to comply with ASHRAE 62. In indoor air purity or quality, number of air changes per hour, acoustics and vibration. There are a lot of municipalities that have acoustic bylaws, if you have equipment that's on a roof, as to what the sound levels can be at the site boundary. So something you really have to consider when you're doing it. On the other part of the equation is, what's the indoor sound level for people in the space when you're deciding what type of equipment to put in. The local climate, mold and mildew prevention, capacities, what's existing, what's proposed, and is there any future expansion? If you have existing equipment, my strong suggestion to you is do a walkthrough of the site to see exactly what you have. Don't rely on as-built drawings, because a lot of times they are incomplete. Ideally, you can do a level 1 energy audit, at least, in compliance with ASHRAE standard 211, to see what you have. A walkthrough can come up with simple things. I have a leaky valve, I have a damper that's stuck, etc., which helps you better analysis. What do we have to do when we're putting this system together? Redundancy. You know, we all know, especially if you have a data center, you have to have redundancy. Does your system require any sort of redundancy? Spatial requirements, present and future. With new refrigerants coming on board, be it A2Ls or CO2 or propane, whatever it happens to be, does the physical size of the equipment change? Is it going to fit? How many people here have seen a mechanical room where it seems all the equipment is shoehorned in? If I have to replace that, you really have to consider, what am I going to do when I have to replace that equipment? Environmental health and safety design. Security. First cost. Dollars and cents always count. But I strongly encourage you not only to look at first cost, but take a look at what the return on investment or what your life cycle cost is on that, and try and convince the people you're working with that that is the better metric to look at. Energy consumption costs. If you have electricity bills for existing equipment, gives you an idea of what the existing is and what we can do to improve it. Operator labor costs. Maintenance costs. I always say a piece of equipment is only good as how it's maintained. You have to have maintenance in your budget. I know for a lot of people it's out of sight, out of mind, but you really have to convey to owners it's very important to maintain. Use the analogy of a car. If you don't change your oil, you don't do the regular maintenance, you're not going to get the same fuel efficiency that you did when it came out of the showroom. If you don't do it, it's going to degrade quickly. I mean, one of the common things I've seen is a lot of people don't even change a filter in their furnace if they have a home. So it's things to keep in mind. Serviceability. Make sure if you're putting something in, is there an access panel to be able to get it? If you have a drywall ceiling and you have a fan coil above, it doesn't make a lot of sense. You have to have an access panel to be able to get it. Reliability. Flexibility. Controllability. Replaceability. Life cycle analysis. I think the challenge is whatever you select for an HVAC system, you are going to live with for the life of that piece of equipment, typically between 15 and 25 years. So it's very important to think, what am I putting in? Is it the right solution for this? It may be different if an owner's going to sell a building. He just said, I just want to replace it and get it done. But I think you also have to look at what is the load. How many people here have been in buildings that have oversized equipment? I'm sure there's a lot of people. Okay? So if you're going to replace, it's not necessarily like for like. Just because I had a 500-ton chiller doesn't mean I put in a 500-ton chiller. If I've done any retrofits on that building, I've changed the lighting, I've changed the windows, whatever it happens to be, done something with the exterior, your load is going to be different. The other thing I would say is, post-COVID, I just saw an article that said 43% of the office space in the EU is still unoccupied. People are working from home or working 2 or 3 days a week. So make sure you take that into account when you're selecting equipment. The sustainability of the design. Seismic protection if you're in a zone where that's required. Filtration and filtration effects. We all saw, the ETF, the Environmental Task Force that ASHRAE put together when COVID hit, was that you should try and maintain MERV 13 filters in equipment where it's allowed, just to have better filtration. So it's something you have to consider when you're looking at HVAC equipment. Changing codes and standards. A lot of the equipment efficiency standards just changed. Refrigerants changing, at least in North America it is, as of January 1st, 2025. You have to take that into account. If you know something's coming down the pipe, that should help in terms of what you're going to select moving forward. What are some of the other goals? You have to look, when is this going to be a startup date? When are the occupants going to move in? Operator training. I think this is a key component. There's no sense putting in a system if the operators aren't trained and don't know how to operate the building. I'm sure people here have seen buildings that have a great DDC system in there, but the operator doesn't know how it works. So he's turned it off and just starting and stopping chillers, boilers, because that's what he understands. So make sure things are trained. Make sure you get a manual together so that if that operator moves on, the new person has something to refer to. Supporting a process such as the operation of computer equipment, promoting a germ-free environment, increased marketability of rental spaces, increasing your income, improving property saleability, Some people will advertise that this building is green. We've achieved whatever rating, be it LEED, BOMA, whatever it happens to be, to try and get more dollars per square meter or square foot by saying we have a green system. This is a building that is very energy efficient. The public image of the property, certification. So, what is it LEED, is it BOMA, Energy Star, or ASHRAE's building EQ? You have constraints, performance limitations, temperature, humidity, space pressure. The codes are updates. The available capacity, equipment, ductwork, pipe size. Especially in the replacement market, if you're going to change the size of something, you have to make sure, if I'm going to go up in tonnage from what I had, is my ductwork or is my pipe going to be able to support it, or do I have to change it? Or can I use something else instead? Available space and the access in and out. How am I going to be able to get things in if I have a mechanical room that's in the basement somewhere that I have to be able to get equipment into? What's available from utilities? As we electrify, can the local utilities support what we want to do in terms of putting more electric equipment in? Or do we have to look at renewable energy sources in order to make that work? Energy budget, what's your consumption per year? Is that code-driven or targeted? Equipment efficiency, operator knowledge and capabilities, and existing building occupants. The architecture, a lot of times you have to work around the architecture that you have. Constructability constraints, what are the existing conditions? What's the floor load, access into and through a building? If something weighs more than what was already in there, can your floor or roof support it? Rigging equipment in and out. Demolition and impact on the adjacent space of existing systems. Sometimes you have to maintain existing building occupancy, use of building and system operation, while you're going to replace the equipment. Ability to phase the HVAC system installation. So it may be a phased project. How are you going to go about doing that in terms of selecting the right equipment for that job? Do I have to provide temporary HVAC if it's not possible to keep the existing equipment online? What's the availability? We all know with the pandemic, equipment lead times went through the roof, and there's still some products that have very long lead times. You can't live with that lead time. You have to consider other options in order to meet the owner's requirements. What is the construction schedule? What is the budget? Once you have all of these things together, you have to do an evaluation. So list what the possible options are. Write down the pros and the cons for each. Weigh the benefits versus the drawbacks. If I go this way versus this way, what's the difference going to be? Building envelope and environmental health and safety concerns. Building envelope is something I think that gets overlooked in a lot of cases. I think you really have to make sure, I may just be looking at HVAC equipment, but if I have an issue with my building envelope, you're not going to solve the problem. Outline the constraints. Go over the owner's requirements. It's really the owner that's living with this, and you come down to a few choices. You have a checklist. Make the decision with the actual decision maker on what the desired choice is, considering all the factors. So in terms of decarbonization, what is it we're looking at? Energy consumption, obviously. If I have less energy, I have less greenhouse gas emissions. Electrifying, we talked about that. Trying to get rid of any fossil fuels you have. Electrifying, is that possible? Sure it is. But could it be a hybrid system? Absolutely. You have to look at what the best option is for what you're doing. What type of refrigerant? You also have to consider the leakage of refrigerant. Does anybody do that currently? Consider refrigerant losses when they're putting a whole life cycle analysis together? Is it an A2L refrigerant or is it CO2, propane, or whatever it happens to be? The manufacturing energy consumption of materials. This is where the embodied carbon comes in. When you consider about how a building is built, you have the raw materials, has to get transported. It's manufactured into something, then it ships to site, it's constructed, it's operated, at the end of its useful life, it's transported away and disposed of. All that is embodied carbon except for what's operated in the building. So sure, everything can be considered there. I'm sure everybody's seen steel, concrete has made great strides in terms of coming up with less carbon intensive materials. You're going to see more and more, and I can tell you from a manufacturer's standpoint, they're all working to try and get you those EPDs, but it may take a year because they need to get a lot of information from a lot of different people. That's why that TM65 that just came out as a guide is useful, because it tells you how you can evaluate that if you don't have that EPD. Is there carbon capture and storage you have to consider, especially in large industrial facilities? How are you going to interact with the grid if you have a lot of renewables? Is the grid able to accept that, or are you restricted? If you saw Daryl's presentation on the new headquarters, we were restricted by the power authority as to the size of the solar array we could put in. And can we recover any waste heat? Heat recovery to me is a big thing with decarbonization. If you can try and use some of that waste heat, recover it, use it elsewhere, it's definitely going to help you reduce your carbon footprint. And what is the end-of-life impact? Okay, normally I have a simple example that I have here. I'd ask you what that is. What do you think the concerns are if I'm going to go from a 6 ton to a 7.5 ton? So let's say the office space, or it was being used as an office space originally, now it's being used as a call center 24/7. There's more people, more equipment. That's why the load's gone up to 7.5 tons. If I have a rooftop, for a lot of manufacturers, it's a shift to a bigger unit at the 7.5 ton range. So when you look at that, what do you have to consider? Number one, structural, weight. Is the roof going to support that? You're going to have a curb adapter because it's a bigger thing. So not only is the weight of the unit, but that curb adapter. Do you have any line of sight restrictions? There are municipalities where you can't see stuff on the roof from a certain distance, so is that going to impact that? Electrical. Obviously a 7.5 ton is larger than a 6 ton and is going to draw more amps. Will your electrical service support that? What about the existing ductwork? Will the ductwork support that additional 7.5 tons? And if it will, what does it do to the acoustics in the occupied space? Is that something you can live with? What type of refrigerant are we going to use when we're replacing this? That could have been an R22 or even a 410A. What refrigerant are you going to use now in that new unit? What about controls? Maybe it didn't have a programmable thermostat or a DDC system. Are you going to put that on that system? What's your budget? All those are considerations. So what I'm saying is, you really have to consider what the choices are going to be. And this is a very simple example. You can get into more complex, but I'm just trying to draw your attention to, you may not be replacing like for like. You may be, instead of this is electric, maybe I'm going to put in a heat pump instead of electric. So with all that, in summary, You gather all the parameters, you list the pros and cons and the constraints, you evaluate the options including decarbonization, and you make the best recommendation with the decision maker considering all the details. The key is there's no silver bullet, there's no one answer. You have to do what's best for you and the client with HVAC selection. And with that, I'd entertain any questions, if there's time. I know we're on a tight schedule, so. The other thing I just wanted to point out that I was negligent in missing is, if you're not familiar, ASHRAE also has advanced energy design guides. So whether it's 30%, 50%, or net zero. So a net zero, and these are all free downloads on the ASHRAE website. So the net zero has one for multifamily, K-12 schools, and small to medium office buildings. I just wanted to make sure people are aware of that if you're not now, to take a look at the ASHRAE.org website.